This video covers everything we did today in 8th grade honors math on Monday, January 24th. The first thing we did was the do now. It's on slide 1 of your ClassKick. I want you to go ahead and pause this video and try slide 1 of ClassKick. All right, so you should have given slide 1 of ClassKick a try. Let's talk about it. We know that line A has a slope of -4 and a y-intercept of 2. We can imagine our equation in the form y equals mx plus b. Remember that m in an equation always represents the slope, and b always represents the y-intercept. So for the equation y equals mx plus b, we know that our equation looks like y equals -4x plus b. And again, we know this because line A has a slope of -4 and a y-intercept of 2. Now, we know that line B has a slope with the same slope with the same sign as the slope of line A. And so that just means that line B has a negative slope. I'm going to call it -5x, but it could be any number. It just says that it has the same sign and a greater y-intercept than line A, a greater y-intercept. So I know that the y-intercept is going to be larger than 2. And so I'm going to call it 5. And this equation would fit the criteria for line B. Now, similarly, I can work out what the criteria are for line C. Line C's slope is the opposite of the slope of line A. So since line A's slope is 4, line A's slope is this +4, we know the opposite is +4 because line A's slope is -4, and a lower y-intercept than the y-intercept of line A. So since line A's intercept is 2, I'll call it 1, and I know that that is lower. And again, these aren't the only correct equations, but they're two examples of equations that fit the criteria. And finally, for line 3, we know that the slope is double line A, so the slope has to be -8, because -8 is twice line A. And the y-intercept is half, line B's y-intercept is half the y-intercept of line A. It's half the y-intercept of line A. And line A's y-intercept, of course, is 2, which means this y-intercept has to be 1. And so the purpose of this do now is to kind of give you some practice on identifying the y-intercept and the slope of these different lines in a way that will allow you to write new equations. Let's take a look at slide 2. Our learning target today is I can use an expression to find when two things like heights are the same in a real world situation. And we're going to focus on one specific example. First, I want you to complete slide 3, 9.1. It says, if you were babysitting, would you rather charge $5 for the first hour and $8 for each additional hour? Or would you rather charge $15 for the first hour and $5 for each additional hour? So I want you to go ahead and pause this video and explain your reasoning. Which one would you pick? So you should be answering 9.1. You couldn't see the question, they're typed out now. Okay, so there's a few different ways you could think about this. And one way is to consider the equation that could be used to represent these two situations. For example, we know that you're charging $5 for the first hour, which means that your y-intercept, where you're starting, is going to be $5. For each additional hour after that $5, you're charging $8. And so you're multiplying each additional hour by 8. And that's the first situation. In the second situation, you're charging $15 for the first hour, but you're only charging $5 for each additional hour. And so one thing to think about is what happens for a given number of additional hours. So for example, let's say that you work 2 additional hours. In the first situation, you're going to end up charging $5 for the first hour plus 8 times 2. And so you'll end up getting $21. In the second situation, you would be charging $5, $15 for the first hour, and then an additional $5 for each of those 2 hours. So you're going to charge $25. And so in this case, you would definitely want the second situation because you would make more money. But what if you were babysitting for a really long period of time? Like let's say it was 10 additional hours. Under 10 additional hours, you charge that initial $5 plus 8 times 10. So you would charge $85 in the first scenario. And in the second scenario, you would charge the initial 15 plus 5 times 10. And so you would end up charging $65. And so in this case, the first scenario is preferable. You're going to make more money in the first payment scheme. And so the key here is that which option makes you more money depends on how many hours you babysit. When you babysit more hours, this higher hourly rate, the additional $8 versus $5, is going to overcome the lower rate for the first hour. And we're going to be starting to work on comparing two equations in this way. So it's important to notice that it does depend on the time. Now, on slide 9.2, slide 4, activity 9.2, it says the amount of water in 2 tanks every 5 minutes is shown in the table. And you can see in the table what's happening in tank 1, that's the second column, and tank 2, that's the third column. And question 1 says, describe what is happening in each tank. Either draw a picture, say it verbally, or write a few sentences. So I want you to tell me what is happening in each tank in question 1. So go ahead and pause this video and answer question 1. So you might have noticed that tank 1 is filling up, meaning that there's more and more water in the tanks. And we can see this because tank 1, the amount of water is getting higher and higher and higher, whereas in tank 2, the amount of water is decreasing. So we can see that tank 1 is filling up, but tank 2 is draining, or the amount of water is decreasing. Now, question 2 says, use the table to estimate when the 2 tanks will have the same amount of water. And so you can either draw on the table or you can write me a full sentence, but I want you to pause this video and answer question 2. Estimate when the tanks will have the same amount of water. So you might have noticed that right around 20, that's when tank 1 has more water than tank 2 for the first time. And so you can imagine that just before 20 minutes, the tanks will have exactly the same water. Tank 2 will be getting close to 600, and tank 1 will be getting close to 600, and they will converge. But in question 3, it says the amount of water in tank 1 after t minutes is 30 t plus 25. And the amount of water in tank 2 after t minutes is negative 20 t plus 100. Now notice that or 1000. Notice that I just set these equations equal to each other, because what I'm saying is at some points, however much water is in tank 1 will be equal to the amount of water that's in tank 2. And so what we can do is we can solve this equation the same way we would solve any other equation. We can add 20t to both sides. And we end up with 50t plus 25 equals 1000. We can subtract 25 from both sides. And we end up with 50t equals 975. And then we can divide both sides by 50. And we know that T is equal to 19.5, which was exactly our estimate before up top, which was that right about before 20, the amount of water in tank 1 and the amount of water in tank 2 would be equal. So the important thing here to notice is that if we set these two equations equal to each other, we can see when they will have the same value. At what time will the amount of water be the same in both tanks? Once you're caught up on slide 4, you can look at the lesson summary on slide 5. After slide 5, all you are responsible for is the benchmark study guide, which is posted in Delta Math. That benchmark test is coming up on Wednesday, so make sure that you take a look at the study guide. If you have any questions, please make sure that you are sending me an email.